Okay, so good evening, everyone. We are back with another speaker. So it is the third expert talk we'll be having for cybersecurity Africa, and we are proud to have with us Mr. Harsh Parekh, sir. He is the co-founder and CTO at SecureZ. He's young, passionate, and as always curious. He started his journey in the field of cybersecurity with ethical hacking around 3 years ago. He and his team at SecureZ has worked with many MNC companies and organizations alongside governments, including Indian government, Dutch government, US Department of Defense, Apple, Oracle, Vodafone, Adobe, BBC, BlackBerry, Samsung, and the list goes on. These companies have been spread all across the globe, and his team has helped them secure the applications and critical infrastructure. So we have Harsh sir with us today to guide us on the fundamentals of different operating systems. So I guess Bonaventure sir, you are here. Before handing over the session to the speaker, I would request you to just address the audience once. Bonaventure sir, you are on mute.
Can you hear me? Is it okay now? Hello?
Yeah, you are audible now.
All right. Good morning, good afternoon, good evening, everyone. We welcome you all to another session of cybersecurity internship, cybersecurity program. So, I want to see that I want to see the numbers, and I need all the students to keep encouraging their fellow mates to join the session. As you can see, this morning the time has been shifted 2 hours ahead to make sure that everyone gets on board. Yeah, so let us stay tuned and then follow whatever the facilitators are teaching and prepare ourselves for the big program that is ahead of us. All right, so thank you.
Thank you, sir. Now, I would like to request the speaker, Mr. Harsh, sir, to carry on the session. And without further ado, you can address the audience and get yourself started with sharing your knowledge.
Okay. Thank you so much, Fazan. Hi everyone. My name is Harsh and I'm the co-founder and CTO at SecureZ. Today we are going to talk about operating system fundamentals and computers in general, and how can we proceed in this journey of be an ethical hacker. So in order to be a successful ethical hacker, you need to understand the two different domains. The first is the hardware, obviously, and the second is software. And both these things work in conjunction. So let us move forward and understand the two domains in detail. A little bit about me. I'm the co-founder and CTO at SecureZ. I was among the top 40 hackers in India on the HackerOne leaderboard last year. I write blogs, and you can find my blogs on notmarshmallow.github.io. I like playing guitar, and if you want to connect with me on social media, you can search at notmarshmallow, and you will find me on Twitter, LinkedIn, Instagram. All right, as well as HackerOne, GitHub, everywhere. So before starting, why do you think we are actually trying to learn hardware? Why hardware knowledge is important in the field of cybersecurity? So see, it is important to understand the machine first and then break it, right? So sometimes when we are hacking an organization, ethically, all right, we are talking everything ethically over here. If you're trying to hack into an organization, if you're red teaming, let's say, and there is probability that their software is not vulnerable at any point. You're not able to pivot yourself inside the network through any software vulnerability or through the network vulnerability. What you can do, you need to understand the hardware as well, right? There is a possibility that there might be some hardware misconfiguration or some outdated hardware system which is vulnerable, using which you can pivot yourself inside the network, or maybe you can manipulate different devices such as IC, which are embedded on the hardware. So everything is hackable, all right, including hardware and software, and we need to understand the hardware as well in order to exploit more vulnerabilities, in order to expand our scope of vulnerability. Hi, sorry, is there an issue? All right. So let us start from basics. We will quickly recap all the basics and then move on to the operating system fundamentals. Okay. So the first thing is a CPU, that is a central processing unit. We are all familiar with it, right? And what is a CPU? Basically, it is the main brain of the computer. That's where everything is connected, including your monitor, your keyboard, your mouse, your speakers, your printers, any external devices such as your pen drive, etc. And basically, the CPU is like a main brain, connects everything and processes everything. Inside the CPU, there are more components such as your motherboard, your RAM, your floppy disk, your CD drives, right? And talking about the CPU has three different subdomains which are important to discuss and to understand as well. So the first is arithmetic logic unit, also known as ALU. Now, any kind of operation which includes subtraction or addition, multiplication or division, it is carried out by the arithmetic logic unit. It conducts all the mathematical functions that occur inside that your computer would be handling. All right. The second is logic unit, also known as logical unit. And basically the logic unit, it gives you a value, either true or false, which is also known as a Boolean value. Let's say there is an operation, okay, and the computer needs to decide whether this operation is successful or not. So the true value simply means that it is successful, and a false value will mean that it is not successful. So the logic unit is responsible for any kind of logical operations and to give the user an output that whether this operation was successful or not successful, like that. And the last is the control unit, and it is responsible for sequence of instructions that the CPU will execute. Basically, let's say you have 5 different operations in sequence. Okay, number one is copy the file, then open the file, and then rename something in the edit the file and then save the file. Let's say these are the 4 operations that you have programmed. So the control unit will execute each of these instructions in line, one after the another, thus managing the cycle of the instructions. Your computer has a lot of operations going on in sync in order to keep itself alive. All right. Just while booting your Windows system or your Linux system, there are a number of operations, there are a number of files that come into play, which all come up alive, and your computer is booted. So who manages all this? The control unit is responsible for managing all these instructions, properly booting your computer, properly deleting your file, or maybe properly executing anything. Even while opening the application, the logic unit as well as the control unit together in order to give you the output. Okay. Moving on. What is a bus line? Now, bus line is basically a high-speed internal connection which is used to control signal and data from the processor to the component. Okay, so let's say you have a keyboard, all right, and you're pressing a key called K or R. The keyboard, it sends this signal to the CPU, but through a bus line. All right, so the entire communication through your wired keyboard or wireless keyboard is carried out through a bus line. And basically bus lines are they work at a very high speed, which gives you better efficiency and output. It outputs really quickly. All right, and 3 major types of buses available in CPU are: the first is address bus, the second is data bus, and the third is control bus. And when you combine all these 3 buses together, usually in the industry, they are also known through the name system bus. So if anyone says system bus, you should immediately know what are they talking about. They're talking about the address, data, and control buses available in the CPU. Third, what is the meaning of a 32-bit processor and a 64-bit processor now? Anyone of you know what is the difference between both of these processors? All right. So now basically, this numbered processors tells us how much memory a processor can access from a CPU register. All right. And basically 32-bit systems can address only 3.5 GB of RAM, whereas a 64-bit system can access up to 1 crore 80 lakhs terabyte of RAM. So let's say you want a computer with better RAM, you want to install 8 or 16 GB of RAMs for your processors. All right. Then you need to opt for a 64-bit processor. Mostly in the gaming section, you must have seen that people opt for 8 GB of RAM, 16 GB of RAM, 32 gigabytes of RAM. Even in video editing industry, they opt for a higher amount of RAM, like 32 gigabits of RAM. So they would require a 64-bit processor instead of a 32-bit processor. And if you have like fewer tasks to carry out, which can be carried out under 4 GB of RAM, 4 GB of memory, you can opt for a 32-bit processor as well. One more interesting thing is that a computer with a 64-bit processor can have a 64 or 32-bit version of the operating system installed, all right? But a 30-bit operating system, you cannot install a 64-bit operating system. So let's say you have a 64-bit operating system, you can install a 32-bit operating system or a 30-bit operating software on your 64-bit operating system, but the vice versa would not work, all right? Next, what are the components of a computer now? Let's talk about the motherboard first. What exactly is the motherboard? A motherboard holds a lot of components on it, such as your processor, your RAM, your like your video card, your audio jacks, input output sockets, everything. So if you look at the diagram, a lot of components are highlighted over here, and we'll talk about some of the major components. So the first one let's talk about is the fan. Now there is a fan connector, obviously, because your CPU holds a fan, and the fan is used to cool down the processor continuously. Your processor heats up a lot when you turn on the computer, when you carry out processes for 6 to 10 hours, your processor literally heats a lot. So a fan is required to keep it cool down continuously. The second is a CPU socket on which the processor is installed. There are chips. Now there are memory slots, basically they're RAM slots, and the RAM, there are various versions of RAM available. Such now in this diagram, they have shown a DDR2 RAM over here under above the memory slots. There are DDR3, DDR4, DDR5 RAMs available. Next is a 24-pin ATX power connector. So basically from your PSU, there is a wire which would be coming out, which is directly installed on your motherboard, and it is a 24-pin connector, which means there are 24 holes in the connector. So if you're like ever building your own computer as well, you need to have all this information. And if you're building your own system, you need this information, and you should be understanding, okay, this is a power connector and where this thing should be fixed. All right. Next, in the olden computers, you would find a floppy connector. Now there are SATA connections available right now in modern computers as well, or as well as old computers. There are USB headers. Basically, whatever USB port you have on a computer, it is connected to the USB headers. And those USB headers act as bus line for you. There is a CMOS battery available. Basically, the battery is used to sync the clock as well as make the CPU running all the time. If your CMOS battery is out of power, maybe, or it is not attached to the computer will not boot. All right. Next are PCI slots. There are audio interfaces available, and there are also audio chip codecs available on your CPU itself. Next, you have Ethernet ports available. Mostly Ethernet ports are available in almost all the CPUs nowadays, because it is very important to have them. They're on the back of the CPU probably. So you'll find them easily on the back of your computer. And there are input-output connector panels, basically the wires that connect your monitor and the CPU. All right, your VGA cables, they are connected through the input-output panel connectors. So let us discuss each of the component in detail now. All right, so you all are familiar with what is a RAM. RAM stands for random access memory, and it is a fast form of data storage. So what does RAM actually do? From this line, we can understand that RAM actually stores your data. Whatever data you're processing, it stores it temporary on the RAM. All right. It is orders of magnitude faster than the accessing of hard disk storage. Basically, what that means is, as compared to a hard disk, a RAM would work much more faster, and it temporarily stores data on itself. So like if you want to retrieve data from the hard disk, it might take a little more time in milliseconds, but as compared to a data stored on the RAM, it is accessed and retrieved much more faster. All right. So the data stored on the RAM, there is one more. So now the data that is being stored on the RAM, it rapidly degrades. So what does that mean? Basically, on the hard disk, every single data is stored permanently. But on a RAM, as soon as you turn off the computer, let's say you keep the computer idle for a longer period of time, this data that is stored on the RAM would immediately be scraped out. It will be refreshed, and that data is no more cached on the RAM. As compared to hard disk, that data would be permanently stored. All right, and the RAM comes, and now the RAM has various forms. There are DDR2, DDR3, DDR4, DDR5 RAMs available in the market, and basically it helps you the more amount of RAM you have in a computer, it helps you to speed up your processes by caching more data, and that's how RAM work. The next is a storage. Now there are two types of storages available. One is an SSD storage available, and second is an HDD storage available. Now SSD, basically we all know, it is a solid state drive, whereas hard disk are the normal. HDDs are the normal hard disks that are available prior in the previous years in the market. The market nowadays has a huge trend of SSDs being installed on the computer, which basically like what is the problem with HDD and why SSDs are beneficial? So basically SSDs help you to retrieve data and store data faster on the computer, on the hard disk, on the solid state drive, whereas the hard disk, it is a bit slower as compared to SSD. That is the first thing. Most of you would be familiar with this. And secondly, there is a higher chance of a hard disk getting corrupted, whereas an SSD might not get corrupt as easily as a hard drive would. So these are the two advantages and disadvantages of a storage device. It is better to get your operating system installed on your SSD and keep your data on the hard drive if you're looking for a faster boot. All right. So SSD can really act fast for transferring data through the bus lines, and if your operating system is installed on the SSD, it will boot much faster. Coming to a more simpler example, let's say you play a game. Okay, you play Valorant, and let's say you have your Valorant installed on your HDD. Now, if the Valorant is installed on HDD, it might take some time to boot. It might also lag. Okay, you might face a severe frame drop sometimes because the hard disk it cannot transfer data at the speed of an SSD. So it is quite slow. But if you have the same game installed on an SSD, it will transfer data much faster, and that's how your game will work much more smoother. You would not face a lot of frame drops, as well as you will get a better experience, and the game will boot much faster. So that is a simple way of understanding how SSD and HDD works. What is a graphic card now? Basically, it's extra RAM that, in order to understand it's simply, basically a graphic card helps you to boost your performance by providing extra memory. It is much faster than your standard RAM, and basically a graphic card is widely used to perform higher end functions, such as, let's say you want to edit videos on a higher scale, use a graphic card. You want to play high end games at 300 200 fps, you install a graphic card. But when it comes to hacking, where do we use graphic card? So let's say you go to brute force. Now brute force is a type of attack in which we spray a huge amount of passwords or any kind of random data against a application in order to guess the correct user password or any kind of data that we want. All right, so let's say you want to brute force millions of passwords against a user or against an application. You would require a graphic card in order to process it much faster. On a standard computer with 8 gigabits of RAM and an SSD, it might not work much faster. Let's say you got 100 threads maximum on that, But when you install a graphic card, you can you can expand this number of threads to 200, 300, or 400 even as well. This is a rough number, a rough example. I'm just trying to give you an example of how graphic card can boost the performance. All right. So using graphic card, you can boost your performance in carrying out your activities, not only in brute forcing. If you're running high-end tools, such as, let's say, there are tools like AMAS or maybe Katana or any kind of tool that you are running on the against the target application, and you want to boost the performance, you can install a graphic card, and that will give you a higher edge in order to carry out a process is much faster and smoother. The chances of your process getting blocked due to a memory block is much lesser, because the memory is easily diversified across the 8 gigabits of RAM, across the standard RAM and the graphic card. Input output devices, we all are familiar with that. Your printer and your speakers, they are basically output devices, or any kind of device that gives you an output is your output device, whereas your input device simply is maybe your keyboard, your mouse, or maybe your mouse pad, any kind of desk that you are using, a digital desk that you are using to write, your joystick. These are our input devices that give input to the CPU. All right. So anything connect through anything, through any kind of device using which you give input to the computer to process something is called an input device, whereas the output device is a device which gives you the output. So screen is the output device, whereas your keyboard will be an input device. That's how you can remember this. Enough chatter about the hardware components. Now let's talk about the fundamentals of operating system and what exactly are the operating systems available in the market using which you can hack. So what are softwares now? A very basic definition of software would be any kind of program which contains a set of instructions. Okay. If I call, let's say, Valorant a software, Valorant is a game, it's a software. What is Valorant exactly? It is a set of instructions, right? The developer has only written a set of instructions. Okay, there would be a character and the character can move like this. There is a UI screen and it will look like this. These are just instructions provided in the software. So that's how you can understand what a software is. And when it comes to software, there are two types of software available in the market. The first is a system software. The second is an application software. Now, what is a system software and what is an application software? By the name, you can understand a system software simply helps us to understand that it is something related to a system. And when you talk about systems, we immediately remember Windows systems, Linux systems, Mac systems, right? And when it comes to applications, we understand this is something related to applications, and there are different types of applications such as Microsoft Word applications, Microsoft 365, different games that you play, video editing softwares. This all come under application software. Now, talking about system softwares, there are 4 different types of operating systems available in the market. There are a lot more than that, but talking about the top 4, the first is a Windows operating system. You must be most familiar with Windows operating systems. Your entire childhood might be around Windows operating systems. The second is Macintosh operating systems. Apple devices, they hold that. The third is Linux operating system. And the fourth is Android. There are a lot more operating systems available in the market, but these are the top 4 that are widely used, and probably everything is built around them. All right. So by understanding this 4 operating systems, it becomes very easy for you to hack into any other type of operating system. So let's talk about kernels, shells, a process, and a bootloader. Okay. So what is a kernel now? A kernel is basically the brain of your CPU. All right. So every single hardware device that you've attached to the CPU works because of the kernel. It is like the heart of the operating system, which allows hardware to perform its own jobs. And whenever you start up your computer, a kernel is the first thing to boot up. And without a kernel, no operating system would work. All right. So you take any operating system, let that be Linux or Windows or an Apple or an Android. Sorry, not an Apple, a Macintosh or an Android system. It requires a kernel which boots up first in order to boot up your operating system. All right. So whenever you turn on your Linux operating system or your Windows operating system, what is the first component that will boot up? It is your kernel. Now, the kernel has certain tasks, certain common tasks that it will perform when it is booting up the operating system, when the processes are being conducted. The first is that it allocates task. All right. So whatever task you have scheduled or whatever task you want to perform, it allocates that specific task to the CPU. You want to turn on, you want to, let's say, start any application, let's say Microsoft Word. So that is an instruction that will pass through the bus line, and the kernel is the kernel is the reason why that instruction is being passed. Without the kernel, this instruction would never pass. And the second thing that it does is it allocates memories to different running programs. If you have high-end programs running at the same time, let's say you are running Premiere Pro and Google Chrome at the same time, and you have 15 or 20 tabs open in Google Chrome. So the kernel is responsible to allocate memory to both of these applications at the same time, so that none of the application would crash and you can carry out both the tasks very easily. The third thing that the kernel would do is it allows you to the kernel allows input instructions from the input devices, and it gives output instructions to the output devices. So if you're pressing let's say keys like K, R, S, anything on your keyboard, the kernel takes that instructions, it passes it through the bus line, and then the specific component then the component that is responsible for understanding the instruction carries out its responsibility. It is sent back to the kernel, and the kernel is responsible to give you the output. Okay. Next, what is a shell? Now, shell is something that you might have, now for the non-cybersecurity guys, I'm trying to explain this in layman so that you can easily understand what a shell is. You must have seen the black screen, all right, in most of the movies or series where they type certain commands. Okay. So basically, that is a representative of shell. And to understand what exactly a shell is, the shell is known as a user interface. Basically, it allows you to execute instructions linked through the hardware to the kernel. This is very typical definition. But basically, what you can do is you can input instructions in order to execute it on your computer. That is a layman term. So what people do through that black screen on green fonts is they input instructions to the computer. Now, when you double click on my computer on your Windows systems, what happens is basically an instruction is set that, hey, open my computer. This is a bluff instruction. A new instruction is set through the kernel that open my computer. What if you give the same instruction to the computer by typing it? All right. So that's what people do through the black screen. They type in instructions all the time, and they ask the computer to do certain things. Let's say you have a broken screen. You can still use your computer through the shell. You can give instructions to the computer, and the computer will carry out the same instruction. All right. We will look how these instructions are provided to the computer in a moment. The next is processes. Now, process is very simple to understand. Anything that is running on a computer is a process. You are running a game, that is a process. There are files that are used to boot up your computer, they are processes. There is a file that basically understands audio interface, it is a process. Any service that is running, it executes a process. So basically, processes are anything that your computer is running right now. Everything that you any list that you look into your task manager, basically it's a process that is running in your computer. And the last is a bootloader. So a bootloader is like a computer program which starts when a computer is booted up. So along with the kernel, a bootloader is also booted, and it helps you to boot your computer faster. Coming next, if you've heard about this term called dual boot, you can basically install multiple operating systems on your computer at the same time. So right now I have a Windows operating system on this computer. All right. I want to use Linux as well for certain operations. So I won't be buying a new computer or a new laptop for installing Linux operating system. I can basically swap memories on my Windows operating system. So let's say my hard disk is 500 GB. I might divide it into 250 slots, and I can install a Windows operating system on 250 GB and a Linux operating system on 250 GB. Like this I can do. How is this done? So the process is very simple. If you want to do it, basically you swap your hard disk memory, you create a free space on your computer, and then you just try to boot up your Linux operating system or your any other operating system on that free space. And you installed a bootloader. So as you're talking about here, what is a bootloader exactly? We'll try to understand bootloader in this scenario. So the bootloader, what it does is it basically detects what operating system is installed on the computer. If you have more than one operating system, let's say you have two operating systems now. So the bootloader at the time of boot will detect that, okay, on this hard drive, I found two different operating systems installed. Now, what can I do? In which operating system should I boot? So either you can set a default preference that always boot in this particular operating system through your bootloader, all right? Or you can like configure your bootloader in such a way that, hey, just I want to choose in which operating system I want to boot. So the bootloader at the time of when you're booting your operating system, every time the bootloader will ask you, hey, in which operating system would you like to boot? Is it Windows? Is it Linux? And that's how the bootloader works. All right. And coming back to the main concept, through dual boot, you can install multiple operating systems on your computer, given that your computer has enough RAM to adjust both the operating systems as well as enough drive space. Now you cannot do like I swap a 15 GB memory out of a 500 GB memory and I'll install the Linux on 15 GB memory. It's not possible because when you install an operating system with the entire GNU interface, the operating system itself, it also requires some space, right? So every file, every bit of those files will take some space on the 15 GB swap, and your entire 15 GB would be filled by the Linux itself, by the Linux operating system. So you need like at least a 20 GB of memory in order to install Linux and store some files. And in future, if you want like more space, you can easily relocate the space in your hard drive. All right. Next, let's say your computer is not compatible with 8 GB of memory and a 500 GB hard disk or 1 TB hard disk, and you are not able to work properly through a dual boot. Both of your systems lag because the RAM and the hard drive are not compatible with how the entire resource is allocated. So what you can do is there is a software called VMware. You can install this software on your computer, and this software allows you to boot operating systems on your host machine. Now, the host machine simply means that whatever system that you are running right now, let that be a Windows, let that be a Linux or a Macintosh. You install a software called VMware on your system, and inside that software, you can boot another operating system. Most of you might be familiar with this, and the people who are not familiar, you can try this out. If you want to like try new operating systems all the time, let's say you want to, okay, a better example would be Genymotion or BlueStacks. If you have ever used Genymotion or BlueStacks in your childhood, basically they are virtual machines. This VM in VMware stands for virtual machine. They are virtual machines that run on your computer. Basically, BlueStacks is not a software itself. Like it can be considered as a virtual machine which runs Android machine on your host computer. Similarly, this VMware is a software that allows you to run any type of operating system. You can install a Mac operating system on your Windows, or maybe a Linux operating system on your Windows, and you can use it. All right. So that is an option if your dual boot is not working properly. Also, VMware is comparably safe as compared to dual boot. Now, why it is not recommended to dual boot all the time? It's simple. If your swapped space on hard drive is corrupted or crashed, you might lose the entire operating system. There is no way of getting your data back easily. Okay, and you have to conduct all the forensics and get your data back. And as compared to a software called VMware, when you install an operating system on VMware, it allows you to back up your systems daily, or it allows you to create images of your or snapshots of your system. So let's say even if your system crashed, there is a full possibility of you getting your data backup every single day, and that's how VMware is much more convenient to use. Secondly, if your hard drive crashes, or let's say one of the space on the hard drive crashes, there is a huge possibility that both of your operating systems would easily be corrupted because the hard drive would not function properly at the end, and the bootloader might not be able to detect any booting operating systems. Those are some complications that take place. As compared to VMware, there are no such complications. If any one of your system crashes, you can just simply reload the entire system and you have your data backup. Every single day you're taking snapshots, you have your data backup. So you can you can conveniently carry out your work. So that's where VMware is more convenient, and VMware is also comparatively much more faster to install, to set up, and to easily start using operating systems. One more better thing is that inside VMware, you can use more than 10 operating systems at once. All right. You have a good amount of hard disk space. You can create a virtual hard drive inside your VMware and can easily use multiple operating systems at once and boot into any operating system. Whereas if you're trying to dual boot, installing 10 operating systems is not a good idea because it will drag your computer to the worst. So let's talk about Windows a little. And when was Windows actually introduced? It is important to understand the entire timeline of Windows, because when it comes to hacking, when you're into network penetration testing, or maybe you're trying to pivot yourself into a network, it is important to understand the entire ecosystem of what host systems are there available in the network and what are their versions. So we'll just quickly look at the versions available of Windows, and it started in 1985 with Windows 1.0. It then introduced Windows 2.0, 3.0, and then Windows NT series came in right in 1995. Most of you might have experienced this. There was a Windows 95 available, and some newer Windows also came in. That was Windows CE. After that, we saw Windows 98. Most of us might have used Windows 98 and Windows 2000. Then after that, then there was an era of Windows XP. This was introduced in 2001 in the month of October, and Windows XP was one of the most widely used operating system. And trust me, it is still used in most of the offices and most of the schools, and a lot. There is a huge ecosystem of Windows XP still available in the market. However, it is no more developed, and it is recommended to immediately update your Windows XP to the latest operating system, because Windows XP has a lot of bugs in it, and there is no more development. So you might not receive any single security update anymore. And there are a lot of bugs still available in Windows XP that might be exploited. So if you find any operating system which says Windows XP installed during your hacking, during your ethical hacking journey for a company, for a client, etc., it is recommended that you immediately ask them to update the Windows XP to Windows 10 or 11 based on their preferences, and which is much more safer because they're in development, they continuously receive security updates. What's next? Then we have Windows servers available. Okay, we got Windows Mobile as well. If you remember, there was a Windows Mobile available in the market. They partnered with Nokia, and they introduced the Lumia devices. After Windows XP, we had an era of Windows Vista. Later on, we got Windows 7, Windows 8, Windows 11, and Windows 10 as well. The latest one is Windows 11 right now available in the market. There are various versions of Windows Server as well. Okay, so when it comes to hacking, there are Windows servers which have different versions, and it is extremely important to understand these different versions as well. In order to hack on a, let's say, 2003 model of the server, there are different requirements. And in order to hack on a 2016 version of the server, or 2019, 2022, there are different requirements as well. Okay, so you need to understand what is the server version that the client holds, and accordingly you have to take your steps, because at the time of fixing the vulnerabilities, you have to mention like, okay, this is the version of the server, and that's how you can fix the vulnerability. So if you don't know the version of the server, you might not be able to give a proper fix to the client, and maybe the vulnerability might not fix easily. That's why it is important to understand the differences, the ecosystem of the Windows. Now, when it comes to security in Windows, there is a term called user account, which is heavily used. And what are the two major accounts available on the Windows system? So there is a local user and there is an administrator user. There are two types of default accounts available in Windows. And in an office ecosystem, you would mostly find every single person holding a local user account, which basically does not has a lot of permissions. What permissions are blocked in the local user account? So you will not find the user being able to manipulate services. You will not find user able to delete system files, or do any kind of, or install any kind of software, uninstall any kind of software. These are some of the major permissions that are blocked on a local user account, whereas an administrator can do all these things. He can install new software, delete system files, or maybe install new system files. You can update the system, uh, manipulate some restricted data. In fact, for a local user, it is also possible to block access to certain regions, to certain files, certain drives, and whereas the system administrator can access it. So in most of the corporate ecosystem and most of the corporate office, you will find that the most of the employees are using local user, and they have configured the local user in such a way that certain parts of the system are blocked, and their system administrator, mostly the IT head or the IT guys, they have access to system administrator and they can carry out all the processes. We already looked at services prior in our prior slide. Basically, the process, because of the services, the processes start. All right. So the services are okay. You want to check the entire list of your services. If you have a Windows system, you can just press on the start menu and go to services.msc, and you will find a large list of services that your current Windows system is running. So those are all the services. Now the services, consider it, there are many different components on your system. There is a audio component, there is a video component, there is a keyboard component, uh, there is a Bluetooth, there is a Wi-Fi. Each of this component introduces a new service to the system, and the service starts because of which the process is going to start. If you like to look at demo of it, just go to services. Okay, so you can see here. Now, these are all the services that are running right now. As discussed, there are services related to Bluetooth. There are services related to time. Of course, your time needs to be updated. There are internal services of your computer, which checks for daily updates, which monitors different actions. You have your browsers installed. So even those browsers run a different service, which basically keeps on checking for update services. And you can even modify whether you want this service to start automatically or not. You can just double click on the service and you can check out over here. It says startup type. You can just select automatic, which basically allows the service itself to decide whether it wants to start at this particular time or not. You can select manual as well. So you have to manually start the service through the application. And there is a disabled button as well. So let's say if this is a service that is continuously disrupting your some functions, all right, you can just block the service. You can disable the service and it would no more be accessible. So there are a lot of services that a computer runs at the same time. There are network services as well, which basically handle your Wi-Fi, your Bluetooth, any internet connection that you're holding. There are services related to the socket, remote registries. Then there are web host services. You have your inbuilt Defender firewall. It also acts as a service. So there are a bunch of services available. So these all are services. And now the major question comes in is that we understand the Windows, the two different factors of Windows, and we are discussing Windows from a quite long time now. So the major question that comes in is that whether Windows is actually secure or not secure to use. There is a huge population in the world that is using Windows operating system in corporate, in their homes, in schools, offices, everywhere. But is Windows really secure to use? What exactly are the faults in Windows that a Linux operating system is covering? Why the internet says that, hey, Linux operating system is much better to use? Why is that? So if you have an answer, keep it saved, or you can just type down in the comment box. And if you don't know the answer, just try to understand Linux operating system, and then you can really answer why why is Windows safe, or why is Linux safe, and which is a better operating system to use. Before that, let us quickly discuss all the directories of Windows. These are some of the common directories that you will find inside your C drive or a local drive. The first is the perf logs, and it basically stores all the log files of your performance. You have a crash, the perf logs folder will hold a file that basically holds the crash log. And anytime you look at that pop, which simply says, would you like to share this crash report with Windows? So this is the log file, which might be shared with Windows, and they can then understand which program caused it to crash this particular program, and they can fix it in their further release. The next is program files, and the program file is a folder which has pre-installed application folders. So let's say if there is a pre-installed application such as Xbox in Windows available, the program files folder will hold a particular uh, system file of that particular application inside this particular folder. So the program files would contain all the pre-installed application folders. Now next is this program files folder. Basically, you can see x86 written in the brackets, and whatever application that the user installs, as well as a by default installed application, they are stored on this particular folder. The next is program data, which is by default hidden, and basically it stores information related to like different components that a computer might execute, such as your DVD recorders or your floppy disk, right? So as well as some predefined software such as Windows Defender, their data is stored in this particular folder. The next is users folder, and this particular folder stores data related to all the users. If you have 3 different users on your computer, a system administrator and 2 different local users, so you will find all the users and their usernames in this particular users folder. And even you can access some of the files of those user folder if they are shared among the users via the users folder. So when you're like pen testing, and if you got access to one of the accounts, you can check the users folder in order to understand if any file has been shared among the users or if there is any shared drive available to the users folder. The next is public folder, and it basically allows you to share files publicly among a list of connected users through on the same network. These are some of the, again, local folders available. The system folder basically holds all the system files, your Windows API files, your DLL files, which are used to boot the computer. And the Windows folder, it holds the Windows installation files. So if you're installing a new Windows, all your new files will be stored in the Windows folder. And you can, even if you take, let's say, if there is an auto backup of your previous Windows installed, you can find that inside the Windows folder. So if you want to recover to your previous version of Windows, or if you want a restore image, a recovery image of your Windows, you can check out the Windows folder if you have any previous Windows data available, and you can easily create a recovery file from there. All right. Going to Linux now. What is a Linux operating system? So basically, Linux is an open source operating system. Okay, sorry, Linux is not. So Linux can be considered as an open source operating system, and exactly we usually say Linux, but Linux is not an operating system. Linux is the kernel. Kali Linux is an open source operating system. So usually people make this mistake that I would like to correct. And Kali Linux is an operating system, or maybe Ubuntu is an operating system, but Linux itself is a kernel. It's like it's a name of the software in more simpler terms. Now it has 3 different components. The first is a kernel, the second is a system library, and the third is a system utility. Now we already looked at the kernel. It is like the brain of the computer, and it is responsible for carrying out all the activities in the system. It takes input from the input devices. It gives output to the output devices. The bus lanes are connected to the kernel, and it connects the hardware and the software. Okay, it is like the heart of the operating system or your CPU. So that is basically kernel. System library. Now the system library, basically it holds a list of files or a list of special functions or libraries that are used to run programs and access the kernel features. So basically, in order to boot up your system, it contains a list of system libraries that are booted along with the bootloader and the kernel that allows you to boot up the system. Or similarly, in order to carry out any process, you'd require a certain library, and that is a part of the system library. That particular library is a part of system library. And the third is system utility, which is a specialized task or individual tasks that are carried out separately. And the system utility carries out this high-end task or maybe extremely low-end task specifically in a swapped memory. All right, so that's how things work. We'll look at some of the features of Linux now. The first thing, that it is portable. Now, what is the meaning of portable? You can carry it anywhere. Well, technically, yes, it is possible to carry it anywhere. But here the portable means is that it works on any hardware in the same way. As I said, Linux is not exactly an operating system. The Linux term is not an operating system. Kali Linux and Ubuntu is an operating system, but Linux is like more of the software, okay, more of the code part. And basically, you can install it on any hardware. You can build anything over Linux. and you can install it on a hardware system, and it works on every single hardware system in the same way. So you can build anything over Linux, and you can install it. Let's say I want to build a smartwatch, so I can build anything over Linux. I'll build my software using the Linux kernel, and I can install it on the on my hardware watch, and the application would function similarly on any other software which is on any other hardware on which I can install. So that is the reason it is portable. If you want to install Linux let's say on a computer, on a 64-bit operating system, and you want to install Linux on, let's say, a smart mobile. Sorry, if you, I should not be speaking Linux again. If you want to install Kali Linux on a 64-bit operating system and you want to install Kali Linux on an Android device, they both will function extremely similar, irrespective of the hardware platform, because that's how Linux functions. The second thing is that it is open source. So anyone can look into the source code of Linux, which is available publicly, and can understand what this particular utility is doing, what is the software exactly performing, and how can I use it in order to develop my own application. And how can I, and since it is open source, the applications built over Linux, they have much more support from the community, and that's how you can collaborate on one single application with anyone in the world. The next is multi-user. So basically, Linux allows you to create multiple users with extremely different permissions as compared to Windows. Windows does not have a lot of versatility, but operating systems built over Linux, they have this multi-user functionality that allows you to swap memories, that allows you to swap applications, that allows you to swap access to files, folders, everything in a much defined, structured way and very easily. So, like if you want an operating system where you can restrict access to some files, you can use a Linux-based operating system, and you can restrict a large amount. Like you can versatilely access and restrict access to certain parts of the computer. Multi-programming, this is also a feature of Windows, but Linux also offers multi-programming, which means multiple applications can run at the same time. You want to use Cherry Tree, which is basically a Kali Linux application to take notes. You can also run the browser along with Cherry Tree. You can do anything. You can multi-program. The file system is hierarchical. Basically, Linux provides a file structure in which the files folder, in which the user files or the system files are properly arranged. So, like if there is any misconfiguration, you must be knowing where to look at. You should directly go to the file system folder and check out what is missing. The shell, we already discussed it. The Linux also provides a shell, and Windows also provides a shell. We'll look at the shell in a minute. And the last is security. So now this Linux provides user security using different features. It provides a password-based authentication, and like it also nowadays you can also like integrate biometric inside Linux, and that's how one can boot inside Linux operating system similar to Windows. However, Linux also provides encryption to data files. So if you have files stored on your Linux operating system, they can be encrypted very easily because there are open source utilities available over Linux. So we discussed Linux is open source. First of all, it has multiple distros available. Now, as discussed, Linux is like the brain. There are multiple distros available, such as Ubuntu. Ubuntu also has different flavors available. There is Kali Linux. Then there are a lot more operating systems available. We'll look at the entire timeline. Security wise, Linux is much more secure as compared to Windows, according to what we just discussed. And since it is open source, it is like quite easy to understand what exactly is going on. Secondly, Windows operating systems, they take our data as well in order to build more efficient systems. Whereas in Linux, everything is open source. No one holds the command of Linux or Linux-based operating systems. So your data is not really captured anywhere. So that's where the security also plays an important task, right? And second, and the last question, is Linux more preferable than Windows, or is Windows more preferable than Linux? We'll discuss it in a moment, but let's quickly look at the timeline of Windows. Okay. So there is a timeline available on the Wikipedia. And if you just go on this link, we can look at how many operating systems actually exist All right. If you just look at this list, it is so long that almost the entire world has developed so many different flavors, so many different operating systems over Linux. And even each of the operating system has its own flavors as well based on the usage. Now, trust me, each of these operating system build has a different use case. All right. You can build, let's say you want to build a robot. You don't have any software, that the robot can function or the robot can understand. You can start building a new software for a robot based on Linux utilities, or you can use any one of these flavors available as open source in the market. So if you just come over here, in 1992, the SLS Linux distro was the first one. Right, it was built over Slackware, which is basically known as Slackware Linux, and the Slackware Linux, right from there, it started SLS, then MNIS. These are all different Linux operating systems that were built in the older generations over Slackware. And each person in the industry or each company, they built a different distribution over the Linux in order to fulfill something that they wanted to fulfill in that particular era, right? And if you come down over here, currently you will find Debian based operating systems available in the market, and you will find like Kali Linux it is based on Debian, or Salin is based on Debian. Then you see, you'll find over here Kali, which is based over a Debian based operating system, and it is most widely used. Then you also find Parrot operating system, which is a little better than Kali because of its interface and how it functions. So probably also find Parrot somewhere over here. See, over here it is Parrot, which is also based on a Debian based operating system. Okay, there are a lot of operating systems, and each of the operating system, like the Vyata operating system, was again enhanced by someone, and like that's how they found a better operating system. Now, if you look at the name, this Vyata operating system might be built for a router. Okay, so the router needs some software, right? So they built something over Linux, and that's how the router got an operating system to function. Similarly, you'll find Red Hat based operating systems. All right, and there are a lot of operating systems like which is most widely used, such as the CentOS operating system is built over Red Hat, and it is one of the most widely used operating system in the market when it comes to ethical hacking and red teaming, or to carry out certain functions. There is a huge list of Linux-based operating systems, and this is seriously endless. There are even Linux utilities available in the market right now, which you can easily install on your virtual machine and can immediately start using it or understand what those functionalities do. You can audit the source code of the operating systems and understand how the systems are functioning. You can start building something over them as well. So this is just a recap, and now it's time for you guys to think whether you would prefer a Linux-based operating system or Windows-based operating system for your certain functions that you would like to carry out. Since you looked at a huge ecosystem of Linux, there is a huge possibility for any functionality that you want to carry out very simply in your organization in future. You can easily find a Linux-based operating system for that. If that operating system is open source, you can just use that operating system in your corporate as well. You can build something over that operating system in your corporate, and you can start using it for your functions. All right. Now let's look at a shell, what exactly a shell is, and certain commands, like how can we give commands to the hardware of the operating system and start using it. Like how can we actually interact with the system through a command line. So I'll just start. Let's just look at this particular slide. This contains a huge list of commands, some of the most commonly used commands. So now the first thing that we are going to look at is commands based on directories. Okay. So this is my shell over here. Let me just boot inside my Kali system. We are executing all these commands on a Linux-based operating system. I have currently installed Kali Linux on my host system. And if you guys want to understand what exactly this, how did I install a Kali Linux operating system on my host system, and how did I boot inside my Kali system, I'll explain that in the last slide of today's session. Before that, let us just quickly look at some of the common commands. And the first directory command that I like to describe is pwd. Now PWD basically stands for current working directory. Okay, it gives the current working directory. So let's see, if I press PWD and enter, I can see that my current working directory is the home directory, inside which I have my username called as Harsh. So if I go one directory back, okay, as you can see, I just went one directory back, and here is my folder called Harsh. Now if I do PWD, I am inside home directory. Okay, before that I was inside my own user folder. Like in Windows, how you have a users folder, and inside the users folder you have different list of users. They have their own individual folders. Similarly, this is the user folder of Linux, and this is the user folder, the current user folder. If I have more than one user over here, there is a user called Harsh and there is a user called admin. So this particular operating system would list down both the users over here, and then I can even go inside another user's folder if I have those permissions. Okay, so we looked at the first command, that is PWD. You can start noting down these commands in a notebook, or you can also try this if you have Linux operating system on your computer same time, so you'll easily remember them. So the first is PWD. It gives you the current working directory, the present working directory. The second command is CD. What does CD stand for? CD stands for change directory. And what I can do is I can ask the computer to change its directory from one folder to another. So let's say if you have a list of, folders like this, okay, there are a lot of folders available. So what you can do is you can, if I want to change the directory from this is my root folder right now, I'm inside the Harsh folder. If I want to change the directory to, let's say, test. Okay, there is no test folder. Let's say I want to change the directory to a folder called targets. Okay, so I can just go inside the targets folder by typing CD, and then I can write the name of the, I can write the name of the folder in which I want to move. And this name needs to be correct. If there are any capital letters, that letter needs to be capitalized. Only then the Linux operating system will properly understand. Okay, so I can just write CD in the name of the folder and press enter. And as you can see, right now I'm inside the targets folder. Okay, if I do a PWD again, you can see I'm inside home, Harsh, and targets. I'm inside the target folder. Let's say if I want to go one step back, I again want to go inside my Harsh directory. What I can do is I can write change directory, CD command, and I can press ... I'll give 2 dots. And this instruction basically asks the it is going to ask the operating system to go one step back, one directory back. So if I press enter, as you can see, I'm again back in the home directory. Over here, the targets is removed, and I'm back in the home directory. I'll again do a PWD. And you can see I'm inside home directory. Now, do you look at this sign? This particular sign over here. Let me just zoom in a little so you guys can easily watch. This particular sign, it basically represents the root directory. It is the root directory. All right. So let's say if I'm inside targets directory, all right, and let's say I'm inside facebook.com, just random. So now I want to directly go inside the root directory. I can do 2 things. I can do cd ... and then again do cd ... and it will give me the home directory. I'll be again inside my home directory. And if I don't want to do that, what I can do is I can write CD, and then I can give this root sign, this particular sign, and just press enter. So it will return me back to the root directory. Now this is not possible with all the folders. All right. So if I directly want to move inside the facebook.com folder, I cannot write facebook.com over here like this. This is a different file. If I write, like, I cannot directly just go inside any random folder. I have to like be inside the sequence in order. I have to type the root folder first, and only then I can type the subfolder. But if I want to directly go inside the root directory, I can just give a command called cd root and press enter. It will give me the root directory. All right. Next thing, let's say if I am inside this particular folder, and now I want to move 2 directories back. As discussed, I can do cd ... enter, and then again press cd ... enter. A different way is I can write cd ... then a // and again 2 dots and // This basically will ask the computer to move 2 step back and again move 2 step back. If there is one more directory I want to go back, I can again write a dot dot slash. If there is one more directory I want to go back, I will again write dot dot slash. And as soon as I press enter, as you can see over here, my directory is completely changed and I'm inside the system folder right now. I have came 4 directories back and I'm inside system folder. If I do pwd, there is nothing. I'm right inside the root folder, the extreme root system folder. Okay. What are the files over here? You can see these are all system files. There's a bin folder. There's media, proc, run, root. There is a root folder. Is there anything that you recap from this home keyword? We were inside this home folder. And inside this home folder, we have our Harsh. Okay. This is my usernames. That's how I can come back to my folders. That's how I navigate through folders or through subfolders in a Linux-based operating system. So the basic command is change directory cd, and then you supply an argument such as your name of the folder. One more thing, let's say my folder name is very big. It's targets, targets. There are literally 7 alphabets. I don't want to type the entire targets word again and again. So what I can do is I can supply the initial letter of that particular folder and I can press the tab key, which will auto-complete for me. This is available on all the operating system. So if you have like huge names, this is, I don't know, type Facebook every time. So I can just type FAC and then press tab. You can give 1 or 2 alphabets, and let's say if there are more than 1 files or folders available with the same name. So if I press tab once, it will not work. I have to press it twice, and then it will list down all the every single word or folder name available with that particular starting letter. And then like you can type the second alphabet and press enter. And if there is no matching keyword available with FA, there is only one, facebook.com, it will directly take you to that. Okay. What's next now? The next command in directories is listing down all the files. And how do you list down all the files? There is a command called ls. And if you press ls and enter, it will list down all the files available in that particular folder. So if I go to not over here, targets, and just give me a second. Okay. Okay, so right now I've created a new folder called test. Okay, and inside the test, there is a file. So let's say if I'm inside this folder and now I want to list down all the files available in this particular folder, what I can do is I can press ls, I can type ls and press enter. Okay, my mistake. Okay, so I can type ls and press enter, and as you can see, it will list down all the files that are available in this particular folder. Let's say if there are more than 1 file available in the folder, I'll press ls and it will list down both the files. Now, I just created a new folder. And how did I create that new test folder available right now on your screen? So there is a command called mkdir, which simply represents make directory. And what you do is you type mkdir command and you can just give any name of your folder, any type of folder that you want with any name. You supply that name and press enter. So it will create a new folder with that particular name. Then you can cd inside that folder as well. You can change directory. You can go inside that folder. And if I press ls over here, currently there is nothing inside this folder. Let's say I want to create a new file inside this folder. So what I can do is there is a command called touch on Linux operating system, which allows you to create new files. And if I do touch krishna.txt, what this basically does is it will create an empty file name krishna.txt, and I'll press enter. I'll do an ls to list down all the files, and as you can see, there is a new file available over here. Now, in order to understand what permissions this file holds and all the different information, there is a command called -al followed by ls. This is an argument that you supply. What you can do is you can type this particular command ls -al and press enter. And as you can see, there is a file available which is created by Harsh. Harsh is the owner of this file. All right. And the size of the file is 0 bytes. There is nothing in this folder. At what time this particular file was created? 1717. It's basically 517 over here at in my region. So I created this file as I created this particular file as 517 in the evening, and these are permissions. All right. So RW stands for read write, R stands for read, and this again R stands for read. We will look at permissions in few more minutes in a different slide. Now let's say I want to remove this particular file available over here in this particular directory. I want to delete this file through the command line. So I can use this command called rm, which simply says remove. All right, and I can just type the name of this particular file that I want to remove. You can even supply multiple files like this if you have more than one file. Let me just create a copy of this file. So right now, as you can see, there are two files available over here. Okay, krishna.txt and rk.txt. I want to remove this file called krishna.txt. So I can just write this command rm, which stands for remove krishna.txt, and press enter. And if I do an ls, this particular file is removed, and you have only one file. Now let's say I want to remove everything that is inside this particular folder. So what I can do is rm, and I can give an asterisk. Now this asterisk universally stands for all in Linux. Anywhere you provide an asterisk, it stands for all that is listed in that particular working directory. So if I do rm all or rm everything or an rm asterisk, this basically is asterisk stands for everything or all, and press enter, it will remove everything. And as you can see, there is nothing inside this folder anymore. I'm doing an ls and nothing is being listed. I'm again and again giving this command called clear, and the clear command, it basically clears out your entire terminal screen. I want to clear out everything that is on the screen to make everything look clean and beautiful. As soon as I press clear, everything is cleaned. Now there is one more alternative of this. Let's say I have multiple commands like this on my system. Okay, let's say I did a lot of dirty work like this, and I want to clear everything, but I don't want to lose access to all this data. I want this data again. I just want a clean terminal to carry out some other function. What I can do is I can press Ctrl plus L on my keyboard, and as you can see, it cleared out my entire terminal. But as soon as I go up, as soon as I drag my mouse up over here like this, you can see I still have all the data. Okay, so that's another command that you can use if you just want to clear out your screen. Press Ctrl L and your entire screen would be clear. You can again you can again go up and access all the data, all the commands that you have inputted to the computer. But if you press a clear command like this, I still have all the data. If I just give a clear command like this, everything would be clear out. I won't get access to anything. Okay, even if I try to scroll up, I won't get access to anything. Next, what if I want to remove this particular folder? This is a folder, all right? If I do ls minus al, you can see this is a folder available, and we also have two different files available, this and this. I want to remove this folder now. We already tried removing a file. Now to remove the folder, what I can do is I can give the rm command, okay, and I can give the name of the folder. This is let's see if this works or not. See, I got an error which says rm, that is a name command, cannot remove the name of my folder Krishna. It is a directory. Now the rm command cannot remove directories. In order to remove a directory, you need to supply an argument called -r and then type the name of the folder. So if I give this particular command, previously we gave rm and the name of the folder Krishna. Now I am supplying a new argument which says rm-r and the name of my folder Krishna. And if I press enter, as you can see, there is no error. And if I do an ls, my current folder has been removed. You can compare both of these outputs, and this particular folder has been removed. Now, there is another command which you can use, which is basically rmdir, which represents remove directory. And if I give the name of my particular folder and press enter, again it will remove the folder. I created a folder over here, and right now I have removed it. All right. So again, the folder has been removed. So let's see what's next now in the list. Okay, so let us try to create a new file again. I'll create a new file. Using the touch command, we create a new file. All right. And now I want to edit this file. I want to understand what's inside this file, or I want to edit some content of the file. So there is an inbuilt editor available in Linux operating system, in Kali Linux operating system, Ubuntu operating system, which is called as Nano. This is very simple to use, command line based notepad version of text editor. You can just type the Nano word and followed by the file which you want to edit. I'll press enter, and this is how the notepad would look. So I can just like write anything over here. Okay, as you can see, I can write anything. This has a bunch of options as well available. The only difference between the notepad, that is Windows based notepad, and this GNU based Nano editor is that everything that you do in Nano is through the keyboard buttons, whereas everything in notepad that you do is based on is with your mouse. All right, if you want to like replace anything, that's using your mouse on notepad. If you want to delete everything or delete anything, you want to save a file, that's using your mouse. You go to file and then save. However, in Nano, there are a couple of combinations of keys that you have to use together in order to save the file. Let's see if I want to save the file. Okay, I have written everything that I want to write in this particular file. Now I want to save the file. So what I can do is I have to press, as you can see over here, there is a particular option available which is called exit, and the command to exit is X. All right, along with this arrow. This arrow represents control. Okay, so I have to press Control plus X to exit this particular editor. I cannot exit this editor. I'm trying to move my mouse. Okay, I cannot exit. I'm trying to move up and down, but I cannot exit right now. Only my cursor would work. Nothing else is going to work. And you will be stuck in this particular editor if you're using it for the first time. So in order to exit this particular editor, what I can do is I can press Control plus X. It will ask me for like whether I want to save this file or not. So it is asking me save modified buffer, which basically means I have modified the content inside this file. I've added some content in the file, and now I want to save this file. So what I have to do is, the Y stands for yes and N stands for no. So I have to do is enter Y over here. As soon as I press Y, it will ask me to write name of the file. If I want to change the file name, I can change the file name over here. Like I can give a 1 or 2 over here. If I don't want to change the file name, I just have to press enter. Okay, so as soon as I press enter, my file will be saved. And now if I look at the file size, it must be having some content. Okay, so as you can see, the file size is 46 and it has some content now. Previously it was 0. And it was last modified at 1725. So my current timestamp has also been updated. Now I want to read the content inside this file. So there is a command called cat, using which you can read the content inside the file. So if I provide the command cat followed by the name of the file and enter, as you can see, the content of the files are listed over here. So that's how you can read any type of file available in the Linux operating system. You can read any file, including a PNG file, a JPEG file, an MP4 file. Each of the file contains metadata. And using the cat command, you can also read the metadata of the file. Usually when it comes to forensics, you will find this command widely used in order to read the file. It's very common. Like you will be using it all the time as soon as you shift yourself on a Linux operating system. Again, I've cleared the screen. So what's next? Let's say there is a file, Krishna, and I want to like read the file. There is a huge file, right? The file contents are very, very, very large. There are millions of lines in the file. Okay, now to read the entire file, it's impossible that the Linux terminal would actually render such millions of lines. You won't be able to scroll millions of lines. So there is a command called less, LESS, and I have piped the command. Now this particular key, as you can see, this character, this is a pipe command which is available on your keyboard. So you pipe this command like this, less. What I'm essentially doing over here is I'm reading the file through cat command, and I am asking the terminal that as soon as you read the file, pipe the particular output of this particular command with another command called less. Okay. What this would do is the less command will help me to like read the entire file without disturbing the scroll. So let me just press enter. And as you can see, the look of my terminal changed. And since there are few very less, like there is very less content in this file, I have like the terminal is listed only this much. But if there is like more, there are a lot of lines in this particular file, you can literally scroll through the entire file through less command. And as soon as you are done, you can press control. Yeah, so you can press Control plus Q in order to exit this particular command. So that's how you use the less command to read large, like extremely large files. Similarly, there is a head command available. So what essentially the head command would do is, let's say I want to like read the top of the file. Okay, I want to read from the top. So I can give the head command, which basically allows me to read the file from the top. As soon as I press enter, see the entire file is listed over here like this. And compared to the head command, there is also a tail command, which allows me to read the file from the bottom. Now, when it comes to large files, we can use the head and tail command in order to like read only specific lines of files. Let's say I want to read only the top 5 lines of the particular file. So what I can do is I can pipe the command like this. I'll first read the file, then pipe the command. Okay, and then I'll give another command, which is a head. -n stands for number of lines. And how many lines do I want to read? 5. As soon as I press enter, as you can see, now it has only listed 5 lines. This is an empty line over here. It is listed 5 lines. Let's say if I want to read only 4 lines, I'll simply copy. See, the output is different. It is only displaying the first 4 lines. Now let's say I want to read only the last 5 lines. So I can write the tail command over here and give it an argument of -n5, which basically says only, okay, read only last 5 lines from the bottom of the file. So as you can see, these are the last 5 lines in our particular file. This is the first line, this is the second line, this is the third line, this is the fourth line, and this is the fifth line. Okay, you can again change it to like -2, and it will only list down the last 2 lines. The output is completely changed. This is first line, this is second line. That's how you can use head and tail commands. So now we talked about removing the file, removing directories, and removing directories using minus. This were the 3 commands that we looked for removing files and folders. What if you want to move a folder now? No, let's say you want to move a file or a folder. So mv is the command that is used to move anything in Linux. I want to move this particular file. Okay, so what I'll do is I'll write the command move 1.txt, and after that I'll give the name of the folder or the name of the entire directory where I want to move. Now, if I want to move this particular file, one directory, what I can do is I'll write the move command. Following, I'll give the name of this particular file, and after that I'll write // This is the third argument that I'm passing. So what this command is saying, move 1.txt, one directory back. And as soon as I press enter, you can see the file from here has been vanished and it is moved one directory back. If I go one directory back and I try to cat this particular file 1.txt, I won't get any errors. And since the file does not have any since the file does not have any content inside it, my particular file has been successfully read with 0 content. But the file has been moved one directory back. Now again, I want to move this to one directory forward. What I can do is I can give this command which says move 1.txt and move this particular file inside the test directory. I can press enter and this particular file has been again moved inside my test directory over here. Let's say I want to move this particular file inside the targets folder, but it's impossible to directly move it inside the targets folder. You see, the problem is that my target folder lies inside my root directory over here. As you can see, this is my targets folder, which is inside my root directory. So if I go inside targets and press enter, it's inside my root directory. This is my root. This is my user's root directory /Harsh. And the problem with, if I go inside test directory now, the test directory is inside Harsh/test. So if you compare both of this, only this much, how is it possible that you will move this test, the content inside test, directly inside the targets folder? It is impossible, right? You cannot just jump from test to target because both of them have a problem that they are both inside the same root directory. It's kind of confusing, but once you, if you really like getting it, this is very easy to understand. So let's say, did you see what I did over here? I was inside the targets directory, and then I directly moved inside the test directory. How did this happen? So this is what you need to understand. This what is the command that I've provided? That change directory. That is what I'm saying. Change directory. Then I give the root sign, which basically says from the root directory, go inside test directory. Okay, where is my test directory? It is inside root, and then there is a directory called test. So let's say you are anywhere in your directory structure. You are 10 subfolders inside a specific folder, and you want to like go to a specific folder which is inside your home directory somewhere. So you can like give command like this, which basically says change directory, go to the root directory, and then go inside this particular directory. Like you can give the entire path of that particular folder in which inside you want to go from anywhere in the command line. So let's say if I want to move, did we already move? Okay, I created a new file called 1.txt. Now, if I want to move this particular file inside the targets folder, what I can do is I can give command like this inside the move, give the move command followed by 1.txt, the file that you want to move, and the third argument would be in which folder you want to move. Let's say I want to move it inside facebook.com like this. So I can give command like this and press enter. And if I go to my targets directory, go inside facebook.com 1.txt, as you can see, the file actually exists over here. And as soon as I press enter, there are no errors and the file could be successfully read with 0 contents inside it. That's how you use the move command. And similarly, there is also copy command, which basically says CP. CP stands for copy. And it's very similar to move command. All you have to do is write the copy command followed by the file which you want to copy. And the third argument would be the file inside which you want to copy. So I want to create a new file called 1.txt, which will be containing similar content of krishna.txt. I can just press enter. And as you can see, there are two files now, 1.txt and krishna.txt, each of which will have the same command. So if I cat 1.txt and if I cat krishna.txt, they both have the same command. You can compare both of these outputs. All right. What's next in Linux? We looked at move, we looked at copy, we looked at touch. Now it's about file permissions. So let us just quickly look at file permissions. So these are some of the permissions that we need to look at. It's very simple to understand and remember. The R stands for read, W stands for write, and X stands for execute. So anywhere you see RWX, basically that particular user has all the permissions called as read, write, and execute. So you can read the file, you can write and overwrite the file, and you can also execute that particular file. If you see only two permissions like W and X, it basically means that that particular user has only write and execute permissions. If you see W, basically that means that that particular user has only write permissions to the file. You cannot execute and you can neither read. So what you can only do is you can write to that particular file. You cannot read that file at all. Okay, and in most of the hacking challenges in your career, in your journey, you will find certain configurations like this, where a lower user has only write access, like for a cron job probably, or maybe the lower user has only read access, and you anyhow need to modify that particular file in order to escalate your privileges. So at that particular time, you need to understand the basics, and it's very simple. RWX, these are only the three permissions available, and that's how you can understand the permissions. So let's say I want to now understand what is the permission of this particular file, 1.txt. So as you can see in the image over here, the first is always the user, okay, the current user. So I can do ls minus al. We already discussed this command. The minus al gives you more detailed information. Come over here, this particular part, only this much. The first stands for user, second stands for group, and the third one stands for others, like any other entity available in the operating system. We will focus over here. Now, this particular column, it stands for, it basically represents me, the current user, and I have read and write permission. Okay. How can I execute a text file? It is impossible to execute a text file, right? Anything that you can do, what's the most you can do with a text file? You can either read it or you can write inside a text file. So I have those two permissions. Now let's say if I want to, like, if I'll just create a new file, and this time I'm creating a sh file. Now sh, it stands for bash. All right, this is a bash file. It's similar to, it's not exactly similar to txt, but it is kind of a file where you write bash script and you execute, similar to your py files, which stands for Python, your JS files for JavaScript. This is a sh file. I'll create a new file in this folder. I'll do ls minus al, and currently, as you can see, this particular bash file also has the same permission by default, that is read and write. Now a bash file can be executed. All right, so what I can do is I can give this command called chmod. Okay, I'll give an argument called +x, which basically says that give this particular file executable permissions, and I'll just write the name of the file. So if I do chmod +x and the name of the file krishna.sh and press enter, there is no output, but as I do ls minus al, as you can see, a new permission has been added to this particular file, that is x. X stands for execution. All right, I can execute the file now. So if I write a bash command inside this, oops, sorry, I have to write the name correctly. So if I write let's say nano this particular file, which, okay, now I'm editing this particular file. Okay, and let's say write a bash command inside this. If you're familiar with Python, in Python you have a print command, and similarly in similarly in bash you have an echo command. All right, so the echo command would simply write this particular output on the screen. So let's say I'm saving this file right now. Let me just show the contents of the file. There is an echo test inside this particular file. Now if I want to execute this file, I'll simply do this. I'll write the bash command over here, and it basically executes the file. All right, so as soon as I press enter, it basically printed the test command. This is because the file can be executed. If I want to like execute any other file, let's say I do copy 1.txt to 1.sh. I created a new file called 1.sh and I copied the contents of 1.txt inside it. All right, so there is a new file called 1.sh, and if I do ls minus al, the 1.sh does not have execute permissions over here. So can I really execute this file? Let's test. It's impossible to execute the file, as you can see. Let's just take a better example. If I try to, oh, okay, yeah, I am the super user on this particular system, so I can execute the file. But if you come to a lower group, this should not be possible. Currently, I'm the only single user on this particular system, right? So I am able to execute the sh files. But when it comes to different user groups, if you have multiple users on the system, you can block the particular execution, and the file cannot be executed. The problem over here in our example is that I'm the only single user on this particular desktop. So the file is actually executable. All right, so let's go to our next command. We'll look at let's say networking commands which are very handy when it comes to security. And the first command that we should look at is whois. Let's say I want to perform an whois on a particular domain name, and this is, let's say this is the domain name that I want to look around. So I'll just type the command whois followed by the name of the domain, and as soon as I press enter, if the domain name exists, it will give me some pretty cool details about that domain, like who owns the domain, from where the domain was bought, or any phone number that is associated with the domain at the time of registration, who bought the domain, etc. So as you can see, the domain is bought from GoDaddy, and when it was last bought, it was last bought in 2022. So the user has renewed it in 2022. It exists since 2002. On 24th of August 2002, the user bought the domain. If I come down, the registrants you can find it over here. There is someone living in Arizona who has bought this particular domain, and there are some more details available. Like usually while buying domains, you provide your home address, right, or your office address. So that particular details would be available over here. At the time of forensics, if you find any suspicious domains in future, you can just run a simple whois test, and there is a huge possibility that the attacker might have their home address available over here. Like they bought a domain name quite in the past, in their 2, 3, 4 years back randomly, and they're using that domain name now to carry out phishing attacks, but they totally forgot to remove their home address or their specific address, something related to them, from the whois information available that they gave at the time of buying their domains. So you can just simply check out the whois information first. Second thing, what you can do is, there is a ping command available now. What is exactly ping command? So the ping command, it allows you to simply, like, number one thing, it checks whether the target server is alive or not. So let's say if I try to ping this, particular website, all right. If I try to ping this particular website, in a minute, I'll start getting responses from the website probably. So what basically, okay, it failed. I think it is blocking our ping commands. Let's take some other. Let's take Microsoft.com. So as you can see, I'll start, the command has started to ping Microsoft.com. And what is this thing doing? It is sending some data, an ICMP packet from our computer to the Microsoft server. And the Microsoft server then responds back with some response. All right, I send some data, so it will respond me back. And that's how it reveals some information. First of all, it reveals the IP address of the server. So if you want to like understand the IP, if you want IP address of one particular domain name, there is a domain name called Microsoft.com, for example. You want the IP address of that particular domain name, you can just give this command called ping followed by the name of the domain, and you can get the IP address of that particular domain very easily. And second thing, just like I want to check whether there is a particular domain name of it, like is Microsoft.com even a real domain name or not. I want to check that. There is nothing. I just faked this domain name, microsoftloco.com. Nothing like this exists, let's assume. And if I try to ping it, see, I immediately got to know that name or service not known, which basically means that this particular domain does not exist. All right. That's how you can clarify whether whether your target domain is alive or not. And let's say if a domain name is not available, but it exists. All right. So your ICMP packets would be blank. It would not send any ICMP packet, and it will basically say temporary failure in name resolution. Using this, you can understand that, okay, this particular domain name actually exists, but it is either blocking my ICMP packets or it is the domain name is down, either one of them. All right. So that's how you can easily, when you're inside your target's network, you can like ping to a specific computer. Let's say there exists a computer with IP address 192.168.0.1. Okay, inside a range of computers, there exists a computer with this particular local IP, and each of the computers are on the same network. So like you can give this particular command, and you can check whether that particular computer is alive or not. All right, like this. So you can you can start from .1, .2, .3, whatever the subnet is. That's how you can check each and every computer is alive or not. Uh, Now let's look at one more command, which is the curl command. Now, when it comes to browsers and operating systems, you will find that it is very simple to download files from the browser, directly from the browser. But when it comes to terminals, through shells, how do you actually download files? So this is quite simple thing to do. You can use the curl command in order to download files, or like in order to retrieve data from the web server as well. Let's take an example. Let's again take Microsoft.com. Okay. If I write curl Microsoft.com and I press enter, okay. Let's look at one more thing before we proceed to curl. There is always a help menu available for each and every command that you type. All right. So, like, let's say you don't understand what is ls command. So what you can do is you can type ls minus minus help or ls minus h, either one of this, and it will list down the entire help command for you. So let's just look the similar help command for curl. And as soon as I press enter, there are a bunch of switches available for this curl command. There's a huge list, and you can like just go through all this particular each and every list, and that's how you get to know like whether this particular uh, like how can you actually supply more data. Let's say I want to supply cookies as well, so I can use the minus minus cookie command over here and supply my cookies in order to authenticate myself on the web server. Or if I want to supply some extra data along with my request, so I can also supply some extra data like this. You get more familiar with curl command once you actually deep dive into further sessions. So let me just clear this one. And before that, let us look how can we actually read data from the server. There must be a switch right now over here. Let's say copy this website, all right. And I'll use the curl command in order to retrieve data. All right, see. So I supplied a particular uh, argument called -i in order to list down the HTTP headers of that particular request. So what did the curl command do? It will basically send a request to this particular domain. And as you can see, the status code is 302, which is basically a redirect. And also it has listed down a bunch of HTTP headers, which are basically web headers, using which you can like understand how and what the domain is communicating, or you have any CSP or not, stuff like that. This is, you will get much more familiar with this in further sessions. This might be a little more complex to discuss, but it is important to remember the curl command. Similarly, there are other commands such as wget as well. All right, so if you look at wget, so let's say if as we're discussing, there is also a command called wget. And if you just go to, yeah, so let's say if I want to download all the content of one particular folder, all right, or of one particular file, what I can do is, let's say this is the file, all right, that I want to download. So if I paste this thing in my browser, as you see, it downloaded a file, an MP4 file. So I can also use the wget command in order to get that file through a terminal. I can write wget and then paste the entire URL of the file which I want to download. All right, and then simply just press enter. As you can see, it created a file with a weird name right now because we didn't supply any output file name. But if I try to cat this file name, this particular file, if I try to cat this file name, okay, they are blocking us for using wget command. Never mind. But wget is like wget is like one other command which would be using like in the further sessions in order to download some file from particular instance. Let's try this file one more time. Mm, yeah, so I'll just simply give the URL of the file which I want to download, press enter. Yeah, see, this one didn't block this. So as you can see, it was 100% successful. It downloaded 93 KB of data for us, and the file name saved is something weird like this for now. I do an ls, and this is the file that is stored. I'll do cat and the name of that file. And this is a mostly a PNG file, I believe. And the PNG data would look junk like this if you try to cat it. So let's take one more example of less command. See, as you can see, the data is so large like this. What I can do, if I want to read the entire data, what I can do is I can just try to cat the file and pipe it with the less command like this. All right. We just discussed it around 20 minutes ago. We can pipe it with the less command like this and press enter. And as you can see, now I have access to the entire file and I can move up and down. All right. Very easily. I can go left, right, this at the right corner. You can find my cursor over here like this, and I'm moving up and down through the entire file. I do not have to scroll from bottom to top. I can scroll from top to bottom and inside the file, and I can press Ctrl plus Z in order to exit the uh, file viewer. That's how it works. And last but not least, we have a couple of more commands to discuss. Let's look at the task manager of Linux. There is a command called ps, and using the ps command, you can list down all the processes. You can give ps minus aux command. Now, this is again a switch, which basically like, gives you a list of certain commands, like certain system related commands or system utility commands. You can give a ps minus h. Let's do minus minus help. Yeah. And as you can see, the help command of ps basically states that you can like give multiple commands to it. You can either ask it to list down a simple list, or like, let's try ps list. So what I can do is, if I want to list down the entire help command, I'll do ps minus minus help list. And you can see there are more switches available now. All right. So let's say I want to like, let's say I want to list down a group, or like all the processes run by a specific group in the Linux operating system. I can do a minus minus group or minus G, and then I can provide the group ID in the argument. So it will list down all the processes that are currently run by this particular group. Similarly, if there is one particular command that is being run again and again, I can do ps minus c and then cat. Cat is a command. Now we are not sure if this particular command is running anywhere or not. But let's say if I want to see like whether this particular command is running inside the system or not, I can do ps minus c cat. And as you can see, there is no output, which basically means that no one is right now trying to read any file in the system. So that's how you can use these switches. Uh, let's do something funny. I want to check if anyone is running ps command. We are also running it. So basically it should list down the command. And as you can see, it listed down the PID is 227. That is a process ID. It's 227, and the command is ps, which is actually being run by someone. You can even provide a user ID like this using the minus u. You can provide session IDs using the minus s, and the ps help command is really big, and you can experiment with this as much as you like. What you can do is you can just do ps minus minus help, and then you can provide any of this argument. Let's say I want the entire help menu, so I'll provide the all command, and it will list down everything. All right, right from top to bottom. I want to list down all the processes. I'll do ps minus capital A, and this will list down. Okay, I think So sudo. Yeah. So like if I want to list down, let's say all the processes, I'll use the -a command, which will list down all the current running processes. Currently, we don't have anything running right on this particular system. So I'll simply do a ps-a, and I have no processes running. Everything is blocked on this particular instance. So as you can see, only one process, that is this particular command, is running, and like that's it. My bash is running and some init programs are running like this. All right, so that's how we can experiment with ps command. It is very much handy. We already discussed OS security and authentication in the Windows part. Some couple of threats that an operating system might be vulnerable to. Basically, viruses, backdoors, and certain logical exploitations using logic bombs. When the operating system starts doing some weird behaviors. Trojan horse, malwares, these are some of the common operating system threats. And in corporates, you will find certain threats such as port scanning. That is the number one threat to the corporate. So there are firewall rules that you can use in order to block port scanning. When it comes to viruses, usually corporates are much vulnerable to viruses as well, through worms, malwares, spywares. These are installed through some of the other means, such as through VBS file or through document or through a phishing email. And what the attacker tries to do is, after installing those files, they try to misuse the systems, they try to steal data or get inside the network and try to find much more vulnerabilities. They can even launch programs remotely, or they can even launch something over the network, over a corporate network, and like they try to steal resources and user files and misuse them from the corporate. That is the number one motto behind the virus. And the last is a denial of service attack. Operating systems are mostly vulnerable to denial of service attack if they are not well updated. If you're still using Windows 7 or Windows XP, you are much more vulnerable to a denial of service attack. If you are in a corporate, mostly personal computers are not much more vulnerable, because no one tries to like attack a personal computer, because those networks are handled by your ISPs. So they're not much vulnerable, but still, if you want to experiment a denial of service attack on your older systems, you can easily find exploits available on the internet for denial of service attacks, and you can try it on a local network. All right, you can set up a local network. You can check it out on YouTube how to set up a local network at home, and you can like connect two different systems on the same network. And like after that, because they both are on the same network, they both can easily communicate to and fro. All right, and then you can conduct a denial of service attack from one computer to another computer. We are familiar with Android. Basically, there are a bunch of Android versions available from 1.5 Cupcake to current Android 13. And some of the Android features, some of the best Android features that provides is that it provides better security as compared to Android 7 and 8. The current version of Android 12, 13, they provide really good features of security. Other than that, they provide newer app support and permissions. Talking about permissions, the older versions of Android 7, Android 8, let's say Android 1.5, 2.3, all these older versions, they didn't had any support for better permission. All right, if an application wants permission to a certain component, such as a microphone, or probably let's say let's say the Bluetooth, all right, the application might easily provide it. There are no there are no specific limitations for permissions in older Android versions, whereas in newer Android versions, permissions are extremely strict, so that none of the malicious application can just try to like access the microphone and start recording everything that is nearby. All right, so Android is comparatively secure. One more thing, Android is built over Linux. All right, so you will find the Linux kernel inside every single Android phone. So as we discussed prior, you can build anything over Linux and use it on any hardware. You'll find Android in smart watches as well. You will find Android in home devices. You will find Android in TV, Android in desktops, Android in mobile phones. This is possible because it is built over Linux, and Linux, since Linux is compatible with every single hardware available. So that's how you can install Android on multiple devices by just making a few smaller configurations in the file system. And lastly, it provides good user experience. Okay, one more thing. As I told you guys in the beginning of our terminal session, that okay, what exactly is this terminal that I'm using? And I should be having a like simple PowerShell, right, on my computer. If I'm on a Windows computer, I should be having a PowerShell like this. So what is this particular terminal that I'm using? Now, this is basically a WSL, which is Windows Subsystem for Linux, and it is available for free. You can just install it directly on the computer in minutes. And once you install the WSL, what you can do is you can install any operating system on your WSL. So once you installed a subsystem of Linux on your Windows host operating system, you can install an operating system now on your Linux-based subsystem. Okay, it's very simple. If you want to install it in similar way and start using Linux, just go to your Chrome and you can just type WSL install. You'll find the first website which has simple instruction. It's a one-liner instruction that you need. Just go to your command line and type this command, WSL ---- install. That's it. Once you do this, it will install the entire Linux-based operating. It will install the Linux on your computer. If let's say you want to install like a particular operating system, a particular distribution, let's say you only want to install Linux. Sorry, you only want to install Kali Linux, or you only want to install Ubuntu. What you can do is you can use this command instead. Use WSL ---- install, and then provide a -d argument for distro name. And you can like type Kali over here or Ubuntu over here and press enter to install that particular distribution. All right. If you are still confused how to do is, there are detailed videos available on YouTube on how you can install WSL. But what is the major benefit of using WSL now? See, I do not want it to dual boot. All right, dual boot takes up a huge chunk of memory for me. And my computer was not even compatible with multiple operating systems on virtual machine. Let's assume that. All right. So what I can do is I can install this literally lightweight subsystem, which forever stays on my computer. I do not have to swap any memory or 20-30 GB. It basically just installs itself on a local disk and starts using your own hard disk memory. That's how it is. That's how simple it is. You do not have to configure anything, and there is like zero chances of data loss. Even VirtualBox can crash at some point, all right, but WSL might not crash. Even your dual boot can crash at one point, but WSL will not. And WSL is compatible with everything. You can install all types of tools and everything on your WSL. In fact, your Windows host system and your WSL operating systems are on the same network, so you never even need to bridge the networks in order to perform any attacks. All right. So it is much more convenient and advisable to install WSL if you're using a Windows operating system and you want to use a Linux operating system on the same operating system that you are using. Now, in order to boot inside my Kali Linux operating system, there are two things that I can do. I have already installed WSL and I've installed the Kali Linux operating system in my WSL. So I got an application named Kali Linux in my start menu. I can just come over here and press enter. And as you can see, it started my Kali Linux over here like this. Another thing that is installed along with this is that I can come to a normal PowerShell computer and I can simply write Kali. This is an alias that has been set, and I can press enter and it will directly boot inside my Kali operating system like this. So I have Kali Linux over here. And what is another advantage of using WSL? So WSL supports every single Windows command as well. Okay, so there is a command called explorer.exe, which basically starts the Explorer window of Windows. But if I want to access the current window of my WSL based operating system, I can do explorer.exe as well. And this particular exe command will also work inside a Linux based operating system or a Linux based subsystem. So that is one advantage of using WSL again. Again, we tried every single command on the WSL. We haven't used any a particular Linux based operating system, like core operating system, we are using WSL right from the beginning, and everything is possible on WSL. So you do not need to like install a Linux based operating system in your further sessions as well. It is up to you. If you want to like go with a Linux based operating system that gives you a better feel of hacking, go with that. And if you have only one computer right now, you want to practice it much more, and you want to set up everything on this one computer, you want to keep things nice and clean, go with WSL as well. It will take less memory, less storage, it is faster, and everything works on WSL. All right, that's it from my side. Thank you so much. And if you guys have any questions, I'm happy to answer that.
Thanks a lot, sir. That was a really amazing session. That started really from the ground level and it went to the commands and the shell. It went really deep into the Linux architecture too. So that was a really insightful session. Thank you for such a nice session. I have already been getting the feedbacks and people are really like they were enjoying the session and they are finding it really informative for themselves.
Oh, thank you so much.
So
Are there any questions?
that's it, sir. We have shared that.
Okay.
No, sir. There aren't any questions. We have shared the feedback form.
Okay.
We'll be getting the responses from the audience soon enough, and we'll let you know in much more detail about how wonderful the session was. Thank you for your time and efforts, sir.
Okay. Thank you so much for
Yes.
having me.